All right. So, presentation mode. So this is a little demo application that I put together to go ahead and just kind of show, how you would go ahead and, the Flux Architecture and, motion, but also the library that I built to go ahead and make this a seamless task to even integrate for first time people who want to actually, put this unidirectional architecture inside of your applications. So a little bit about the architecture itself. The architecture is built, the library itself is built off of Reflection, Java Reflection. There is full concurrency on the library's end when it comes to actually emitting reactions and actions back and forth between stores and views. Okay, so that's good. You won't have to worry about that piece. So this application, I was actually making this for my daughter because I got my degree in applied mathematics, by the way, so my daughter gets to get dreaded with learning math very early in life. So,
why are you going to torture her like that, man?
Got to. I got to. I have to. All right, so it's called Math Hack. So, getting this application in your project, you can do a Control N. I'm a shortcut guru, thanks to Ben.
Yep. I would.
And you can go ahead and simply compile this project, my architecture library, into your application. That will be in the presentation that Ben had. And so, just to kind of show you my file structure here. So as you see, I have an action, my dagger, have my stores, and of course, if I had more than one view, you would see a view folder. Okay. Inside of my action folder, I have a single action creator. Inside of my store, I also have a single store. Okay. I also have my reactions interface inside of my store because that is where you would create your reactions for your store to emit out to your views. And here is my actions interface for my action creator methods. Okay. Back to your question when you were, talking about, the different stores. 100% correct, like Ben was saying. Okay, you will create stores based off of the specific business logic that it will entail. Okay, never cram business logic that has no correlation with each other in the same store. Okay, same for action creators. I am a huge proponent of the one-to-many model of activities to fragments, right? So I'm a single main activity to many fragments, which means usually I have fragment action creators. They're named based off of my fragments, and I have fragment-based stores also that are named based off of my fragments that clearly define what business logic is where, and usually my fragments will be listening from those stores also with React methods. Okay, so it keeps it very clean and clear. So now, little of the setup of my main activity. Okay, so this library, of course, you will have your own application class. You have your own application, create your own application extension file. And inside of it, I use dependency injection heavily. How many are familiar with dependency injection? Love it. So, with...
That sounds bad.
Huh?
Yeah.
That sounds bad.
No, it's good.
What dependency injection? Oh, no, that's awesome. So, just a little so you can see how we set this up. So as you see here, my modules, you'll have an action creator module, your application module, this one I gotta delete, that was just different, and your store module. All right, so now in your application module is where I actually provide my Flux engine. This line right here, of course, when this all happens and you run your application, this will go ahead and actually provide the full application to my engine. Okay, my engine actually takes the liberty of registering all activities and fragments by overriding full lifecycle methods of create and destroys, so you guys don't have to worry about it. Also, so that will be there. Now, your store module, just kind of same thing, you know. Go ahead, be able to inject your stores, be able to inject your action creators. This is probably the most important, like I said, that module. Going ahead and preparing your actual Flux object here, okay? Doing it here allows you to not think about it anymore. Once your application runs, you're good to go. Use the library, all right? Now in the main activity, as you see, I'm sure you guys are aware of butter knife and things, so yes, I love injections. So just to kind of, you know, start as far as a flow, as you see here, the very first thing that I do here is I inject my action creator and my store.
I'm sorry, can you jump back to presenter view?
Yep.
Yeah, please.
I'm sorry.
Gosh.
You like it? Jesus. All right, so with your stores, okay, you will want to go ahead, if you use dependency injection or if you don't, right, your action creators and stores, the same concept applies, right? You'll need an instance of all your action creators and stores, depending on where you're going to use them, right? The best place to do that is inside of your single main activity, all right? Your stores, you won't have to do anything with except make an instance of it. Because when you create that instance, it will go ahead and then register, as you'll see when I get to my store, it'll register that store to actually receive action items, okay? So here, like I said, I just use dependency injection. The very first thing that I do here is I go ahead and call my action creator start quiz. And that flow will go ahead and simply start my application. It'll show me the first problem as Ben showed you. All right. Now, what happens after that, though, is, say I click 2. I think I have my debugger on, as you see. Okay. So, this is my action creators get next problem. I will pass it my text. From there, my action creator will receive it. Okay. I will go ahead and then give my type inside of a mid-action, and I will also pass it the key value pair of the answer. Okay. What that happens is my library takes over in the mid-action method, and it will then go ahead by reflection call the correct store method that accepts this particular action type. How we do that is this. The custom annotations in my library are your action custom annotation and also your react custom annotation. Both of those custom annotations, you will supply them action type or reaction type respectively. Okay? My library will go ahead and find those, compare them, and call the correct one, and pass the action or reaction object to them. Okay? So as you see here, it called the get next problem. My library found this, called it, passed it the actual Flux action. I do the work, and then I go ahead and emit reaction here, pass some data, because this data is important to me to know if I'm on my final quiz problem or not, so my view can act accordingly. And then after that, my library kicks in again, and our view gets it. And it updates. And it's that simple. So that unidirectional flow that you saw that been explained, you know, is very important with the Flux architecture. And a lot of ways that you see Flux, you see it differently based off of if you're using dispatch, someone might use an event bus, auto and things where the issues like you were saying, those things might come into play. A lot of people have custom annotations with that. So I took all of those things and Buddy will tell you, Ben will tell you, created a library to remove the possibility of thread crashing, also remove the possibility of one thing that I disliked, and that was all stores or all views all getting called no matter what, right? Because to me, that was a very bad way of, when Facebook created Flux Architecture, to go ahead and say, well, all views, go ahead and get this response and decide if you should do something, right? Same with stores. All stores get it. So to me, that's horrible performance, calling, 15 stores and calling their methods and passing an action to it, and then them going through switch statements to realize only one of them needed it anyway, right? Which is why I handle that with Reflection and compare methods on multiple threads in the background to call the exact method that only needs to get called, right? Yes?
Mentioning reflection, are you saying that you're doing runtime reflection or you're doing compile time annotation process?
I am doing reflection, runtime reflection when it comes to the work of deciding all methods that have React annotations, all methods that have action annotations, and that all happens on an executor pool with multiple background threads, and the timing is very, very fast. And another key thing to note about your store with this library is this. You will annotate your stores with a store annotation. Okay, so when you create a store, you'll annotate it, store annotation, and as you see here, I use injection, as you see. If you didn't, then you'll simply go ahead and do a flux.getInstance. That'll allow you to go ahead and get an instance, and you can simply pass it here if you don't use Dagger. Okay?
Well, you should use Dagger.
And the next thing from there, you would go ahead and simply register this store as an action subscriber. Okay? And it's important that you use this and not class, because you want this instance of this store, right? Because I cache that in my library and makes life very easy. Okay? Very simple setup to start listening. And as you see here, action annotation in your store, give it an action type. These action types directly correspond to your actions in whatever action creators you make. Okay, so you simply will just place them there. And as you see here, I keep things very clear in regards to it starts quiz, it shows next problem. Same for views. The best thing about this is that with a lot of the custom implementations of the Flux architecture with event bus and things like that, TDD is difficult. And the reason being is because it's difficult to have independent modules at all times with using event bus. Okay? With this, as you see, if this was RX, all of these would be observable methods, and they will go ahead and just emit when they're done, which can be TDD'd. And they also can be TDD'd this way by simply creating your own Flux action objects and validating that you receive what you need to receive. Okay, so one thing that's important about these is I update this current position state inside of here. So I can create unit tests to validate that each of these methods update that accordingly. Okay? Yes.
Sorry, more questions.
Nope, you're good.
For your best practices, do you find that if I need to persist state, say somewhere like this, do you do persistence within the same store? So if your math store you wanted to persist where you were in your problem set, would you have another store that's like math persistence store that's kind of hidden away, or would it be in that sense?
It would be in here. Stores will have specific state. Okay? So this store right here is responsible for, calculating the results of your quiz and showing you the next problem, getting the next problem set. So because of that, it will be responsible for any state that needs to happen when it gets in action to do something else. So it can go ahead and know where it was before it takes action.
So building off that, if you'd expect, your ideal use case for this would be you would inject things like your persistence layer into that store that you're using, and then you had something like what he was talking about, like a network state, right? Let's say someone was sending you math problems because people do that. Right? If ever there was some kind of conflict in the UI versus your store, you'd have to either deal with that conflict yourself or just say the store is true.
Exactly. So, for things like that, when I hear the word confliction or conflicts, right, there should never be a conflict between your view and your store. If there is, then that means one, you're not handling failures or you have no fallbacks, and those fallbacks happens in your store also because they'll happen based off of something not going down a happy path.
I think actually an example that Ian was pointing out was, for example, you have like a to-do list, right?
Yes.
And your to-do list is network based. Maybe you have some kind of subscription or even like a chat app, right? And in chat it's a little easier because you have things like a timestamp that kind of implicitly orders stuff by. But if I have a to-do list and I say, okay, this is done, and maybe the to-do list has sub actions and people can add those actions. If I say something's done and that's in the process of being pushed on my device's main thread, I have another thread that's in my store that's listening for network change and saying, oh, well, little Johnny added a subtask, which is walk the dog to this thing. Well, which is right? Is it done or is it not done because that's action there? And so what it seems like though that your solution would be to say that your store would have to reconcile the fact that, okay, well, he did this action here, it conflicts with the state there, so you do have to implicitly do that conflict management in your store.
Yes.
But you are foisting that on the store as opposed to have to do anything else. So based on that then, you have to have more states, more reactions that says, okay, well the reaction to a task that's done, but one that was changed is a when in conflict state to the view. The view says, oh, well, you said it's done, but Timmy did something else. So literally every action, every state must be enumerated in a way.
So also think of it, so even in that instance, right, if you have a to-do list and you go ahead and you say it's done, right, and someone else goes ahead and they add a subtask to it, okay, you have to remember already that your backend is holding that state. So anytime you get any call back from your backend, you're going to go, so if you push it up and you say it's done, right, and you come back to that, right, it comes back to you. So locally, yours say it's done, okay? Your backend's determining to update your state on that side. So you also have to understand the separation of that also. If you say it's done, it's going to go up to the backend, and the backend's going to store it as done, as state. That user's going to add a subtask, and it's going to go up, and now your backend's going to go ahead and update that to not being done anymore, add the new subtask. Everyone who, has that subtask in the database under their name will get a push notification. Their phones will go ahead and update their to-do list locally on the devices. So that alone is a whole other conversation of how that should even be properly handled in the first place. Because, like I said, I've built, web systems, backends also before I even came to mobile. So that question alone, shouldn't actually be handled on the device in the first place if it's user-to-user communication. Local state only happens on user devices on Android.
I'd say offline is probably another way.
And even on offline, you have caching, and that's what services are for on your local device. Your services are there to go ahead and register if you have connectivity, don't have connectivity. If you don't have connectivity, caching is in progress to go ahead and store anything that may need to be updated. When you do have connectivity again, you're hitting your backend again to go ahead and update your local data store.
So really, you're kind of prescribing if the mobile client got something wrong, tough case.
Now, really tough case, your mobile client shouldn't technically never get anything wrong. Your mobile client should be directly communicating with your backend servers at any given time, at any given change. And if only reason why it shouldn't is if it's offline. And when it comes back online, you should immediately be shooting up to your backend anyway to get that data.
I think, like I said, I think that Ian also pointed out, and I'm pointing out instances where, yeah, they're actually, I went to it was John who said it. Someone mentioned kind of the source of truth. at some point, it's very possible and likely to get to a state where someone says that it's one way and it's really not. And they can happen in two states. You have two folk, they're both offline, and someone adds this, someone adds that, and they both go up to the server at the same time, and they can have a timestamp, they can have an action. But again, it seems like, and it's not a problem, it's a good thing.
No. I know exactly what you're saying.
It seems like the prescription is like, well, you either say the state is such that it's what the source of truth for something else is, in this case the back end, or you enumerate the failure case and
exactly.
tell the user, hey, look, this case is that I understand from my back end that there was this conflict. I'm going to tell you about that, and I want you to handle it and change it in some such way. Hopefully, you might get it. And those are both perfectly reasonable.
Exactly.
Exactly. And it seems like your prescription is like, yeah, let the source of truth be outside of your client. And that's totally
Exactly. The local truth will always get updated by, the actual truth outside of your client anyway, right? And I mean that's exactly, right? So I mean, which again also provides a very clear and coherent, and also best development practices also. I mean, especially if you're building your own backends and client sides, thinking about that architecture alone, with peer-to-peer communication, ends up allowing you to remove the possibilities of those things by implementing caching service and failures and saying to yourself, well, there's only so much you can do if this happens and someone is offline. So this is what we do. We stay with local state until we can go ahead and update and validate by online state, right?
You said
Did I say doo-doo? Did I say doo-doo?
what you do?
What to do-doo?
Sorry, I had to. I'm sorry.
You guys are childish. Did I say that on camera?
Yeah, I was going to say, we recorded that.
Oh, man. But yeah, so we went over the flow. We went over how to implement, pull this down. Any questions as far as getting the library into your, the best way to get it into a current project or a new project, and a boilerplate of just getting initial classes and hierarchy set up. Any questions on that?
I got one comment, one question. I like how you're using annotation to kind of remove a lot of the boilerplate of wiring up this whole architecture. That's pretty nice. My question is, can one action generate multiple reactions back to the same view or back to the view?
So one action, okay, if you want it to, no. No, I'm just playing. As you see in a store, a reaction is simply you just creating it, right? So if you have if you here in these reactions right here, I mean, you can go ahead and, do this, right?
And then change the action.
And change the reaction type. Okay, so say for example, in your question, doing something like this would kind of make good sense in regards to landscape mode, right? 2 pane fragments. Okay, you got 2 fragments, and you may want one to update this way, one to update that way, based off of a single action of a delete in a list. So this action still gets it. You still do the work that updates the state because the action still involves the same state. But then you need to go ahead and both of those fragments, one reacts by deleting and updating a recycler view. The other reacts by updating the text view. And so there you go.
So you're saying that's actually totally within best practices to do multiple interactions?
You can.
You're
You're reacting in any way you're reacting, and it's still unidirectional, right? It's nothing wrong with that at all.
Yeah.
Nothing wrong with
ultimately, the views are done. Essentially, this architecture
And
allows
they're not
the views
dumb.
to not have to do a lot of thinking. They just have to hear and ask for things.
Yeah.
You know.
And which
the store is where all the intelligence is.
So like you see here, like even how I name these methods, there's not a single piece of business logic in these views at all.
Which is great.
Both of these reactions right here, even though it'd be silly, I don't know why I would do that, but I could send them both out based off of a single action. And they'll do exactly what the view is only supposed to do, and that's update view state. That's it. And it'll do it very quickly without having to think about it. Any kind of computational time. Simple. Your recycler views. I'm a huge fan of recycler views. I love the recycler view.
You never stop talking.
I never stop talking about it. I hate when I see a list view. I can't stand it. So I use this in my recycler views also. And in order to use it, this is why I created a public method for you to manually register your reaction subscribers. So I manually register your activities and fragments by overriding lifecycle methods. But for example, recycler adapter. Okay, in the constructor of that, I would go ahead and simply do using my library, a flux.getInstance.register. So it kind of just be a flux.getInstance.register reaction subscriber, and I would put this. And now my recycler view can go ahead and simply listen to reactions to delete, update, remove item. Very easy. No clickback listeners, anything else. Nothing. Very simple. Right? So this is also why I went with the annotation pattern. As you said, I hate cluttered code. I hate it so much. I hate having to set up so much stuff just to use something.
That's why I made this, right?
So I made this very simple. Go ahead and use React annotations inside your views. Only worry about views updating views. Give it a type.
Easy one.
And go ahead and go. If something isn't updating, like I said to you, if something isn't updating, I know the only place it could be wrong is in a store. I don't have to look anywhere else anymore. I don't have to look in this store. I don't have to look in this class, that class, because they're inheriting from a parent class, and then I don't have to do any of that anymore.
I see what you're saying.
Wouldn't you have cases where multiple stores respond to a single action then?
You shouldn't.
Why not?
Because if multiple stores,
Well, with your library, you should.
actually, period, you shouldn't, right? A store is meant for, a store to me should be created for specific business logic and state, right? So if you have more than one store reacting to the same action, essentially, I wouldn't recommend it. You can though if you want to.
It's
you
possible.
you can. It's all like everything you're saying is, but just like the emitting multiple reactions. You can have two stores both with a action method that has the same action type.
But you saying
They'll both get called, and they'll both go ahead and update the state in those stores. But to me, essentially, and again, that's just to me. I would never see a reason that I would have two different stores do something different on action. If I'm walking, if I'm gonna make a peanut butter and jelly sandwich, I don't really know why I would go ahead and have me and someone else both put peanut butter on the same slice of bread.
I guess the example would be that you were talking about having a cache layer and a network layer.
Mm-hmm.
So obviously you want the cache layer to return immediately. So how do you have the cache layer return immediately, the network return later, but then also the views might register and unregister at different intervals, right? So you could have multiple cache requests, multiple network requests happen before even the first network request finished.
So a network request and a caching request wouldn't actually happen off the same action though. Caching requests.
Well, purely from the read perspective, right?
Mm-hmm.
So you have a local store and you have a network store. Or would you have one store be both?
Say that again? So what do you mean?
Right, so you have an activity can have one or more views.
Yeah.
Well, 0 or more views, really. So if an activity has multiple views like fragments, they're all going to make requests against your data store for data, right? And if you have a caching layer, the caching layer should return nearly instantaneously. So you could have a situation where you can have one or more requests for this data to be displayed, which could
From
also
where,
trigger off
though?
a network request, right? Because if you have a cache, there's going to be a point in time where you want to refresh that cache. So how do
And you're right.
effectively, like typically you would do like a map reduce, right? Like with some kind of delay. So when you go to request for something, you might wait like 100 milliseconds before really doing the request, just to make sure that if other things also make the same request, you don't duplicate work.
I mean, that's possible, but I mean, that's possible, but I mean, how we create caching services anyway, though, is that, I mean, there's a time limit where any view should request anything from cache versus requesting something from network. So, and when it's requested from network, if it has to get requested from network, that kicks off the actual updating of cache. So that should have never actually conflict. There's a time to get from cache, and then there will be a clear specific time to cache is not valid anymore, so we don't get from cache anymore. We shoot the network, and since we shot the network goes ahead and updates cache at that point. So, I mean, again, I think things like that comes to,
Well, does that like push you towards having like a God class for the networking? Because if you have
I create API store, a single API store.
okay.
So there's nothing else that handles network calls except my single API store. And so if I need to go ahead and, and as far as caching itself, remember caching is a content resolver. So, a true caching service is built off of a content resolver. So if I need to get something from cache, I'm technically going ahead and getting it from an SQLite database, hitting my content resolver anyway. So I'm just shooting an action for that cache data. And I may have a time date stamp in there to let me know if, that view, the business logic to say, well, yes, send this back to the view because the date time is okay, or no, go ahead and kick off network requests instead to go ahead and get new data and then go ahead and store. All right, so that would still all stay in stores to handle all that business logic. But I do have a single API store, and I would have and that API store itself will go ahead and make any network data calls. As far as caching, wouldn't necessarily have a caching store. You can have a caching store to go ahead and just simply, hit back and forth to the content resolver itself and do business logic to just separate the two. But the actual network will indeed go ahead and write directly to that content resolver, which it can because it's handling business logic when it gets new data. So it's, your cache won't ever write to your content resolver. Only your networks will. Only your network call will with new data. Your caching will just always get updated based off of your content resolver. So that store data, technically you wouldn't store the state inside of it. You would only use a caching store simply for business logic manipulation to decide if it's okay to use that
So
data.
you're just saying the caching would just keep emitting the results. The network layer would never actually talk to these.
Exactly. So the API store itself, depending on if we're talking directly caching versus network, then technically yes, it would if it got the data. So if the view had to go ahead and say, I'm going to the caching store. The caching store says, wait, I'm not valid. My data's not valid in the content resolver, so we need to hit the network instead. Once that hits the network store will then go ahead and kick back to the view. Because how you should do it is that at that point, when that caching is invalid, you should send a reaction back to the view that the cache is invalid. So then your view will go ahead and now call the API action instead. And so once it calls the API action in your API store, it will it'll bring the data down, do the business logic, update the content resolver now at that point. So now your cache is update. And then it'll go ahead and emit a reaction to your view now saying, okay, here's the data you want.
Okay, so in the router dispatcher, there was a dispatcher? So
Dispatcher? Yeah.
Dispatcher.
So can the dispatcher act as a map reduce in that case?
Essentially, but with...
Because you could have the situation of multiple views making the request for something, for a resource, right?
Of course.
Right, so...
I mean, yeah, 100%. I mean, well, again, that goes back to, how many, fragments you have on a single screen. I mean, if you have a single fragment on a screen, only one fragment is going to be making any requests because other ones aren't visible anyway.
Well, I'm just going off the assumption, like you talked about services and other things
Mhm.
being used, so it's potential that outside of your own realm of authority that multiple things happen at the same
Yeah,
time.
but exactly. Those things will happen at the same time. As far as how you architect, if some things won't directly update views. Like for example, our caching service, it doesn't directly update views at all. Our caching service simply runs, our view checks to see if the data is valid, and if it is valid, we'll go ahead and just continue to use the cache data. If it isn't valid, we shoot up to API endpoint to get the data instead and then restore that data. So we don't ever we still stick with the unidirectional flow. We don't ever break that unidirectional flow. It's still either we're hitting cache failed, we need to send a reaction back to the view. The view says, great, it's listening for a cache failure reaction or whatever you name it, and it knows now in that method when the view gets it, it's calling action creator to whatever action that hits that API endpoint now. And then that store will then go to the view. So it will, anytime you have to ask yourself if, look at if you're sticking to a unidirectional flow. That will go ahead and take a lot of confusion out of a lot of things. If it's not unidirectional, then you probably shouldn't be doing it because it's not an architecture at that point anyway if it's not unidirectional. And, there's a lot of different ways to handle failures and fallbacks and all kind of things, but the most important thing is developing in a unidirectional sense. And that's with caching, that's with, fallbacks, that's with anything. If you have an error, if you don't have connectivity, if your caching's invalid, the very first thing that should happen isn't to go ahead and do another, business logic module. It's tell your view so your view can go ahead and again stick to that unidirectional flow and call the action that it should call now to try and get that data some other way. All right, and that'll keep it so you don't have to think about, well, this view's conflicting now with this, or this is calling this action and this is calling that action. If you stick and make sure it's unidirectional how it's supposed to be, you can make sure that those things will indeed get called, correctly, because my library, it's not using an event bus. My library is caching and storing classes and methods and hash maps and, using reflection to get any method that fits the specific criteria of that action that you've defined inside of it. So unlike using a dispatcher, that wouldn't happen. Using a dispatcher, anything that is subscribed to an event will go ahead and get that. Dispatcher doesn't do any checking system on specific events, right? You can give anything, this, like a store can call anything inside of it with a lot of custom, Flux architecture. With this, only a specific thing is called, just so we can indeed try our best to stay within that unidirectional flow and not let anything cross itself by doing that.
Well, I gotta call it here. We're getting close to that time limit for the venue here. But I'd like to thank Nigel and Ben for coming to speak with us.
Thanks for
Thank you.